हेलो फ्रेंड्स, इसके पहले पार्शियल डिफरेंशिएशन के लेक्चर्स देखे होंगे मेरे आप लोगों ने। आज फिर एक नया लेक्चर स्टार्ट कर रहे हैं अपन। सो नाउ सी होमोजीनियस फंक्शन कि व्हाट इज मीन बाय होमोजीनियस फंक्शन। अ फंक्शन f of xy is said to be homogeneous if the power, that is also called degree, of each term in fxy is same. Just see this example. Suppose we are writing fxy equal to x cube plus 3x square y plus y cube minus 4xy square. आप लोग को यहां पर चार टर्म दिख रही है, 1 2 3 एंड 4, और चारों टर्म में सम ऑफ द पावर्स ऑफ x एंड y सेम दिख रहा है, that is 3 3 3 and 3. So clearly it is a homogeneous function of degree 3. इसको और एक काम कर सकते हो आप लोग. Let us take x cube common. x cube अगर कॉमन निकालोगे तो it is 1 plus 3 times y by x, then plus y cube by x cube minus 4 times y square by x square. Or again we can write this equal to x cube into 1 plus 3 times y by x plus y by x whole cube minus 4 times y by x whole square. Now see the bracket. This bracket is clearly in this form, f of y by x. So here our result is f of xy equal to x cube f of y by x. तो यहाँ डेफिनेशन ऐसी बन गई है, a function is said to be homogeneous if it can be expressed in the form x to power some number into f of y by x. Now see this example. We have taken here x to power 1 by 2 common in numerator and denominator x to power 1 by 3 common. These two together becomes x to power 1 by 6. Now this term is of the type y by x, f of y by x. So here it is a homogeneous function of degree 1 by 6. आप लोग यहाँ चेक कर सकते हो, न्यूमरेटर में दो टर्म है, दोनों की डिग्री सेम है, दैट इज 1 by 2 1 by 2. So numerator is a homogeneous function of degree 1 by 2, and denominator, it is a homogeneous function of degree 1 by 3. So overall effective degree, that is 1 by 2 minus 1 by 3, it will be 1 by 6. तो आप लोग ऐसे भी डिग्री निकाल सकते हो. So it is a homogeneous function of degree 1 by 6. आप लोग को एक डेफिनेशन और बता रहा हूं कि if f of tx ty equals to t to power some number into fxy, then fxy is said to be homogeneous function of degree n. See the same example. Suppose we are writing f of xy equal to x to power 1 by 2 plus y to power 1 by 2 upon x to power 1 by 3 plus y to power 1 by 3. Now let us find f of tx ty. x को रिप्लेस करना है by tx और y को रिप्लेस करना है by ty. So it will become tx to power 1 by 2 plus ty to power 1 by 2 upon tx to power 1 by 3 plus ty to power 1 by 3. You can take here t to power 1 by 2 common from numerator and t to power 1 by 3 common in denominator. So it will become t to power 1 by 6, and this remaining term, it will be definitely f of xy. So here f of tx ty equal to t to power some number into f of xy. It means that fxy is a homogeneous function of degree 1 by 6. Some another example, u equal to root x plus root y upon x square plus y square. Here numerator की डिग्री दिख रही है 1 by 2 और डिनोमिनेटर की डिग्री है 2. So effective degree will be 1 by 2 minus 2, that is minus 3 by 2. It means u is a homogeneous function of degree minus 3 by 2. आप लोग इसको ऐसा भी कर सकते हो. Now this example, it is x to power n sin of y by x. x को अगर रिप्लेस करते हैं by tx, तो it is t to power n x to power n sin of ty upon tx, that becomes t to power n x to power n sin of y by x. It is f of xy. So n will be degree of this homogeneous function. Now see this example, u equal to sine inverse of this. Clearly it is not homogeneous. Now why it is not homogeneous? Because we cannot express this problem in the form x to power n f of y by x. Now, depending upon homogeneous function, see one very interesting theorem. If z equal to f of xy be a homogeneous function of xy of degree n, then x del z by del x plus y del z by del y equal to, it always equal to n times z. Now see the proof. So we have given here fxy is a homogeneous function, and since fxy or z is a homogeneous function, so z can be expressed in the form x to power n f of y by x. इस फॉर्म में लिख सकते हैं इसको. Now let us find del z by del x by applying product rule. So it is first del by del x of second, then plus second del by del x of first. So it is x to power n. Now derivative of this f of x. तो f of x की डेरिवेटिव हो जाएंगी f dash x, that is f dash y by x, and further derivative of y by x with respect to x will be minus y by x square plus f of y by x, derivative of x to power n, it is n x to power n minus 1. Now let us multiply this by x. So it is x del z by del x. एक x cancel हो जाएगा. So it will remain minus y x to power n f dash y by x अपॉन में एक x और बचा हुआ है तो इसको ऐसा लिख सकते हो. Then plus n x to power n f of y by x. Let us suppose that it is number 1. Now similarly, find del z by del y. So it is x to power n is constant. f of y by x के डेरिवेटिव हो जाएंगी f dash y by x, and further derivative of y by x with respect to y will be 1 upon x. So it will become now x to power n minus 1 f dash y by x. इसको y से मल्टीप्लाई कर रहे हैं, so y del z by del y, it will be y x to power n minus 1 f dash y by x. Let us suppose that it is number 2. Now just add these two. आप लोग अगर दोनों को ऐड करते हो, so this term will totally get cancelled, बचेगा रिजल्ट इतना this, and it is nothing but n times, now it is z. Now see the quick look. Z is a homogeneous, so Z can be written, we can write in this way. Differentiate करो with respect to x, similarly with respect to y. दोनों की वैल्यू सब्स्टिट्यूट करना है यहाँ पर. So we will get this result. It will be equal to nz. Now see the example. Depending upon Euler's theorem. Verify Euler's theorem. So clearly, it is a homogeneous function of degree 2. आप लोग को क्लियर दिख रहा होगा. 3 टर्म है और तीनों में सम ऑफ द पावर्स ऑफ x एंड y सेम है, that is 2, 2 and 2. So it is a homogeneous function of degree 2 in terms of x and y. It means x del z by del x plus y del z by del y will be definitely equal to twice z. ऐसा रिजल्ट आना चाहिए. सो लेट अस फाइंड हियर. सबसे पहले हम लोग निकाल रहे हैं नंबर 1 को डिफरेंशिएट पार्शियली विथ रिस्पेक्ट टू x. तो ax स्क्वायर की डेरिवेटिव ट्वाइस ax, ट्वाइस hxy की ट्वाइस hy. देन नंबर 1 को डिफरेंशिएट विथ रिस्पेक्ट टू y, सो ट्वाइस hx प्लस ट्वाइस by. दोनों की वैल्यू सब्स्टिट्यूट करो यहाँ पर और रिजल्ट आ रहा है 2 टाइम्स दिस, but it is nothing but z. So our result will be twice z, and hence Euler's theorem is verified. So friends, it is all for this lecture. So just stop here.